some applications of hydraulic circuit with some schematic of conveyor system, etc. And basically, there will be many more such linkages which are used along with the hydraulic system to, to cover either right movement, positioning movement, or like linear actuation for a certain distance, or rotary actuation, etc. So there are various such mechanisms which are coupled with the hydraulic system in order to drive right the actuators and deliver certain outcome. And as I told you, any of the mechatronic system we consider, final outcome is mechanical in nature. Okay, linear or rotational, delivering a force or positioning, alright, or accelerating, or maybe the actuator application or mechanical requirements, output requirements will be driving. It will work with a screw knot, racket pinion, or chain drive, belt drive, gear drives, etc. Coupled with that hydraulic system, there may be indexing, there may be cams, there may be spring anchors, some variable speed arrangements, either conical pulley drives, etc. But these are all just to give you idea. We are not going into details about this mechanisms, etc. Just to give you idea that it's not that only hydraulic system will deliver what we want as a mechatronic output. The output, the hydraulic system will deliver and will coupled with certain mechanisms to deliver the required output. Okay. Now, coming back to our important aspect related to heat. See, we are looking for certain displacement or positioning or certain other parameter control while we are driving the mechatronic system. We need certain features. So good positioning, reproducibility, that is nothing but a precision. And hydraulic systems to a large extent provides such a precision with a very low hysteresis, almost nil, right? When we will talk about maybe micro electromechanical systems, so there also we can use some other approaches, piezoelectric materials, etc. for actuating certain, but then hysteresis may come into picture, and that's why sometimes a very small hydraulic pumps which is displacing only microliter fluid, not what we discussed till now, right? Big systems, right? It's only microliter fluid also possible, which I will try to see in the later stage of our classes how those systems look like. Then stable temperature characteristics are most of those applications we need. Otherwise, we may have to have temperature compensation by some other means. Okay? Then low driving energy, of course, it is desirable, and small size and lightweight, they are also desirable aspects, etc. Just to make every one of you are very much familiar nowadays of this Land Rover, right, system and mode. So there is one system which now at present rover is analyzing the soil samples, correct? It is using LIBS, LIBS, laser induced breakdown spectroscopy technique. Okay? So of course I am just giving you an example. It's just to make a preamble basically. Now when in the 2008, we started working with ISRO to develop such a soil analysis system. Okay, so we use this approach, this technique in our laboratory. If later on in future, if you want to see, we can see that this unit, the size is a laser system is around 800 millimeter. Okay, and with a driver. Okay, system with a driver to give the laser output, and spectrometer. So laser comes out, it gets focused, material gets ablated, plume is formed. This plume is captured using a spectrometer, which is around 200 millimeter plane. The size of maybe this is maybe 75 millimeter in each. This is around 200 millimeter plane. This is 400 millimeter high, 250 millimeter width. Length is also 400 millimeter also. Right, total weight around 10, 12, maybe 15 kg at its approx. Okay, not exactly 15, 16 kg. So laser to ablate the material, plume is formed, plasma is generated, then a spectrometer to analyze, and data is to be collected. So it is fed to the computer, and you can see right, some information about elements, atoms, elements, etc. present in this sample. Okay, this is the sample. So here, fine. So this is, let's say, soil or some other sample. Okay, whatever it may be. It may be any sample. This is what we develop. Now, if you put this right and send it to moon, it will never reach. It will never be able to lift up, right? Because the payload is so large. They want to integrate multiple systems. See, there are 4 sensing units at present on the rover. Okay, and they want to integrate multiple such units, etc. It's not possible to send such a system. So what system they have sent, configuration is the same. India, this is the pulsed India laser, pulsed neodymium yard laser, yttrium aluminum garnet. Okay, I am just confusing you, all of you. You did not remember. It's ADR laser. It's pulsed, a nanosecond pulse. So peak power can go up to megawatt. Okay, because 1 millijoule divided by 10 nanosecond will end up with 100, right, kilo or more. So you can imagine that the intensity, power is large, focus, so intensity is large, and it ablates the material, and the intensity over here is 10 raised to 6 or 10 raised to 8, around 10 raised to 8 to 10 raised to 10 watt per centimeter square. Okay, it's very large. It can ablate any material. Okay, diamond also. Okay. Now this system, what is mounted at present in the rover, where it is, the laser is 75 millimeter long, maybe 25 millimeter width. This is this. This laser. Okay, driver unit is a small.
ये लेज़र है जो कि पल्स जनरेट करेगा, फिर ये
10 times smaller.
यहाँ पे इंटेंसिटी
10
ज़्यादा
times smaller.
है, तो पता नहीं है कुछ करके स्पेक्ट्रोमीटर के पास
10 times, no, 800
स्पेक्ट्रोमीटर एनालाइज करके सीपीयू में सिग्नल देता है।
Okay.
What is this doing basically? What is this system doing?
Can you explain the?
It produces, it ablates the material, produces the plasma. It ablates means it removes, it vaporizes the material to plasma state.
For soil, it's vaporizing soil.
So soil is there, it will ablate the soil sample, make it a plasma. Now soil consists of various elements all these things will get into plasma, and when plasma cools down, all these elements, atomic elements which are excited, those excited atoms will come down to the ground level. At the time they will emit optical emissions. Those optical emissions are captured in spectrum. So what you see, the spectra, if you go back to Pragyan outcome, you will see some like some emission lines. So aluminium, calcium, sulfur, or whatever, iron, silicon, something you will be able to see. All those
And that,
things.
so that is power source.
So this is the power supply.
So what is the significance of dimension here?
It's a small. See, it was so large when we did experiments here.
Okay.
The actual which is loaded on this is so small.
So it was developed in IIT Madras.
We didn't develop this. We developed the whole process for high vacuum conditions, because when the plasma is generated in very high vacuum, how plasma will really behave, how will it expand, then only we'll be able to capture the data. So how shall we do that? On one, the vacuum is 10⁻⁻15 bar. Okay, this is 1 bar here, 10⁻⁻15 bar. And in our lab, we performed the experiment up to 10⁻⁻7 or 8 bar. Okay, it's still lesser than actual. Okay, much lower than actual. But we could find out that the plasma expansion after reaching a particular vacuum state is not that much. So we will be able to capture this information when we go to moon. Okay, so that was the plan. The first plan was finished it was 2015 or so. Okay? But then it took some time. It got delayed. Afterwards 2021 or 2022, right? They made. But now it really started working. So this is what I want to say. And of course, the whole lower system itself is a very good mechatronic example, right? Remotely going there, getting transported, getting landed. Landing is not very easy. The things can get crushed, right? Because of the jerk which it will experience. It doesn't know on which soil it will lay. Right? It lands and the soil is something different, it can get plunged also, right? Anything can happen. And when it is landing, because of the this landing pressure, the soil may also produce as a very dirty environment, right? Lots of this, it may get blinded. It won't be able to see, and it may then end up with a difficult situation. You can imagine unknown terrain, unknown parameters, remote control, right? Thousands of kilometers away. So it's a very good example. And in that, from there, something comes out and starts communicating, right, with the rover and analyzing the things.
So this is done before landing. This is done before landing. What is this process called? So what is this process called? Complete process?
This is rover is doing at present while walking around on the moon. LIBS, laser induced breakdown spectroscopy. It is one of the sensors. There are 4 more sensors, different analysis. It's analyzing oxygen, something is analyzing something else, temperatures, etc. This is one of them. Okay, anyway, I just wanted to boast that we have developed. That is big aside, but smaller size, right? It makes the things